Hey, how's it going, guys? Last time, while we left off in the last lesson, we created this great function which uses native JavaScript console.log to point out a scene memory pointer, or more specifically, a pointer to a string in the memory at memory location of 16. So in this lesson, then let's use the example to read that string data from our and put it to use in the browser. Step 1 then is to access our WebAssembly module exported memory object wasm.instant.export.memory, which is a type of file assembly memory, as we can see there here on the object prototype, with a single property of buffer, which if I click this is an array buffer. An array buffer is relatively a new concept to the JavaScript. Is basically used to store binary data from consumption by JavaScript array buffers. Also, pixel length, so the size of a particular buffer is 65,536 binary byte, which is equal to 64,000 decimal bytes or 64 kilobyte, also referred to in WebAssembly as a page of memory. We will cover in this bit more detail in the next lesson though, so let's visualize that. Then we have a pixel length of a binary data, which is essentially a piece of memory. Somewhere inside that binary data we have a string hello from C stored as a power chord C code. We also know while in the memory string that data starts, this being provided to us by the char or char pointer. We are logging out at the moment 16, also stated in our WebAssembly text here. What we don't know, however, it is when receiving a memory pointer like this where data ends. So start reading the data from memory and offset of 16, but up to where should we keep reading JavaScript to know this endpoint? Then we'll have also to provide it the length of the data it needs to read. Don't worry if it sounds a bit complicated right now. It will be make more sense in a minute. You know a C code, then let's modify a string lab or move the string out of this function and assign into a variable char pointer. Message equals hello from C, passing into the string log as a first argument that pointer's message. Same as before, but we know what this first argument really is. It's the memory offset of the data. So rename that function in the header to make a bit more sense. Offset, also adding a crucial second argument length, being the length of the data to store for read the offset, which we can pass to string log from read by saying string length message. As the name suggests, string length is the C function that returns the length of string. This function being part of C string library, which we have to include right at the top. Use a standard C include declaration string.h, another header file for this library we are including. It's simply a part of C's call library that we are now calling whichever function our import declare to be string log with two arguments offset, at which the data starts in memory, and the length of the data, which is everything we need to read it. At the moment, of course, we still have to console.log import as a string log, so we will have to update that as well. Build that, download and update the WASM file in our project with the new one. Then I will change the string log import to a new functionality called ReadMemoryString, which will have to read string out the WebAssembly memory const readMemory signals equals a function with the argument offset and a length as implemented in our C code. And first thing to do is convert our WebAssembly memory from an array buffer to uint8 array. Const call the string buffer equals uint8 array. A uint8 array is again a newer data type in JavaScript, which is essentially a standard array with a only 8-bit integer as its value, also known as typed array. This integer represents a piece of data from buffer, allowing us to easily access to conduct this array. Then we need pass it buffer from which to get the data was the instant that export.memory.buffer, the offset at which the get data from in this buffer, offset being our pointer of 16, and we will stop reading the data or the length of the data. So what we have to here is now extract data from our WebAssembly module containing that string, finally decode that data text using the JavaScript text decoder API. String equals to new text decoder, calling decode with our string buffer that string data, which will again log out for no save this, head back to our demo project and reload to we have to all this take effect. Cool, great. Again, remember kick our now string log with the string data offset and the length in the memory enter. And it works. We log out that string having read directly from our WebAssembly memory, that still we are still only logging the string out, have no real way of using it on our code, which can't exactly use it as a return value from this real memory string function, as that's being called in our WebAssembly module and not us directly. So the approach I like to use EventState of get rid of this log, a message to notify and make use of this new string, which exactly we are now notifying the window. In this case, so the browser will calling dispatch event with a new custom event of WASM value, meaning a WebAssembly module sent us a value. This could of course be much more specific to a specific events, but this will do for now sitting on that. Custom event detail property, the new string will also need to listen and receive these events. Again, on the window object, add event listener was a value with a callback. Make that callback event string. In here we can now use the string as we want. As soon as we receive, it will just log out received a new string from C with the string.detail as we dispatch it. Remember, WebAssembly does not have access to DOM, so using a strategy like this is great solution from directly manipulating the user interface from WebAssembly. Just something to keep in mind: restart the server, reload, call the exported greet function again, and we get the log message from that event handler that covers the basics of reading from via the assembly memory. In the next lesson, we will take a closer look at the memory object. At this point, it seems like a lot of effort to parsing a simple string. Just keep in mind we are doing for this the sake of understanding what's happening is we will simplify all this later with the help of mscripton.